part 2. See if we can get it going again. Oh, great. Yay. All right, so let's get to the proper slide. Okay, so here we are. So ray FE actually starts from here and it goes in that direction. So they're different rays but on the same line, different starting points. What's another ray that I could have named on there? GF, another different ray. But notice that even though the rays are going in opposite directions, my notation always has the ray above it going to the right. Okay? And that's what you're going to do. Because rays could go up, tilted up and to the right, so you're not going to put the ray in the direction it's actually going. I mean, sometimes it will be. Alright, so then a point. A point is a dot that just represents a location in a plane or in space somewhere. Points have no dimensions. Yeah, we can see a point, but when we see a point, we're really seeing the intersection of 2 lines or the intersection of 3 planes or something like that. It's really hard to see an exact point. And then your notation for points, if you look at the line above it in the ray one, your notation for the points on that line, you would just say E. We name a point with just a capital letter, E, F, or G. Those are the 3, point E, point F, or point G. You have to put the word point in front of it. A single letter represents a point. And then if you're in the back, you might have to stand up to see this, but I'll read it out to you. Space is a boundless, 3-dimensional, set of all points. A boundless, 3-dimensional set of all points. So, aside from the fact that space is boundless, this room contains part of space, right? This room is 3-dimensional. Then you have 3-dimensional, you have volume, and this room contains volume. The problem with this room is it's not boundless. Space, the final frontier. We don't have notation for space. And then the last definition on this page, again, if in fact you're going to have trouble seeing this, we had yesterday with collinear, meaning on the same line. So coplanar must be on the same, says points that lie on the same plane. Points that lie in plane. Now it says nothing about them having to be in the same line. You can have points that are not on the same line, but they're all on the same plane. They're considered coplanar. They might not be collinear, but they can be coplanar. They could be collinear and coplanar at the same time. So it just depends on where they're at. Remember, these points here are collinear. Because they're on my whiteboard, they're also coplanar. But if I put another point up here and name it point A, these 4 points right here are not, but aren't they all coplanar? There's a difference in your definition. All right, does everybody have that written down so I can go back to the first slide? I'm going to test you on it. You ready? All right, so we're going to go back to slide 1. Wow, it'd be a lot quicker if I went this way, huh? Okay, so here's slide 1, eraser notation. I'm going to add a couple of things up here. I'm going to add a bunch of points. Oh, I didn't mention the notation for a line, the second notation for a line. So we'll talk about that here, and you can put it on the other sheet. Let's name this plane. So the whole plane. There's all kinds of different names you can give for the plane. So raise your hand and give me one name for the plane. Give me one.
ABC.
Okay? He's chosen ABC. Can we use that name? Go back and look at your definition. What does it say? What's your definition of a plane say? Somebody read it out for me.
Flat surface that extends forever in all directions.
Okay, so within that, and this is not your fault, we have not talked about, I don't remember if I said anything, we cannot name, when we name a plane, points that are all on the same line. One of the points has to be off that line. So we can say A and B, or B and C, or A and C, but you have to remove one of these, and like, let's say D. A, B, D, we can name that plane that way. We cannot name it this way because this line can be contained in two different planes. I could put a plane straight through there. Ooh, let me grab a piece of paper. What if I put a plane straight through here this way? See how now I have two planes that have that same line in it, and I don't know which plane we're talking about. So when you do name the plane, name it with 3 points only that are not on the same line. So name it again. Another one. A, B, and then G. There you go. All for the same plane. Okay? So any 3 points that are not on the line. What if I named it BGA? Is that a different name, or is it the same name as something else? It's the same name. So if I asked you to name this plane 3 different ways, and you named it these 3 different ways, I'm only going to give you credit for naming it 2 different ways. Question?
Can you tell the difference between the 2 G's?
Did I put 2 G's on there? Oops, you're right. So let's name this K. How about that? I didn't mean to put 2 G's. You got a point. Ha. All right. Couldn't you also name this plane capital cursive S? Just a capital cursive S. That's another way. All right. So let's name this line right here. This line right here.
EK.
EK. Yes.
So we should do that instead of...
If it's named with a capital cursive letter, you can use that name. If it's not, then you can't. Does that make sense? So if I didn't have that S there, you wouldn't have been able to name the plane capital cursive S. No. Nope. All right, so this is one way, EK. If you named it KE with a line above that, would that be the same name or a different name? Same name. So you can't name it the same way. What's a different name for that same line? FK. Or KF will be the same as that, right? And what's another way? EF. Or FE, right? And then last way, this is what we didn't talk about. You could name it cursive Q, lowercase q. Lowercase q's name lines. Or lowercase letters name lines, cursive letters. Uppercase cursive letters name planes. And notice I don't have to have line Q here. The fact that it's lowercase and that it's cursive implies that I am naming a line. Question?
So Q is always for a line?
Well, in this case it is. It could have been a cursive P, K, any letter of the alphabet. Okay? Let's name this line segment. The whole line segment. GJ. With a segment above it. Is there any other way to name that line segment? JG. Would that be the same name? Which I would accept either one. There's only one way to name it, either JG or GJ. Like that, right? What if I named it HJ? Is that a different name for the same line segment?
It's a different line.
It's a different line segment. So be careful with the line segments. With a line it doesn't matter, but with a line segment it does. All right, how are you going to name this point? This one right here? D, just D, right? And then what about the ray? How are you going to name this ray? That's right. So it's either AB with a ray above it, or and it's the same ray, but just a different name, AC. A has to come first. The ray is the only one that you can't flip-flop the letters to. Let's name a ray on this line. Any ray that you want to. FK. I heard EF. Is that the same or a different ray?
Different way.
Okay, FE is also a ray, and EF is a different ray, by the way. They are not the same rays. They're different, because one's going in one direction, one's going in the other direction. It's like the Scarecrow in The Wizard of Oz. Yes?
Would BC be the same name for like
On this one?
yeah.
Technically, no, because it's got a different starting point. I mean, technically, rays don't actually have a fixed distance, but BC on this is different than AC, because you have a different starting point. But you could do AB or AC, that's okay, same starting point, going in the same direction. Those name the same rays, but if you change the starting point, now you have a different ray. Any other questions on any of the notation of naming something up here? Okay, so then we're going to go to flip your paper over to the third slide, and then turn your books to page 9. No, sorry, 13. So it says refer to example 13, or example 2 on page 13 in your text, which is this. So I'm going to try to jockey back and forth. We'll see if it messes up my video. So here is the picture that they are referring to. Right there. All right, so your first question on your paper says, name a point that is not collinear to F and C. So here's F and C. Let's start with a point that is collinear to F and C. What point is collinear? E. These are all on the same line, right? So then name a point that is not collinear. Give me one point. A is one. D is another. And B is the other one, right? So let's go back to your answers. They should look like this. Uh-oh, I think I hit it twice. Gotta love technology. Oh, there we go. All right, so here's your question, and there's your answer. So point you to B or D. Those are the ones that would not be collinear to F and C. Then your says, identify a point that is not in plane N. So let's go back and look at the picture. I want you to oh shucks. I want you to discuss with the people around you which point or points are not in plane N. So talk amongst yourselves. All right, stop. Do you have a question? No, not right now. Stop. Stop. All right, so remember this is your plane right here, so it's like a piece of paper that you've got right here. And then you've got a pyramid coming straight off of that paper, right? Which point definitely is not in plane N? And here's your cursive capital letter N. E definitely, obviously, is not in there, so E is one of your answers. And then many of you did see that F is also not in there, but notice how they've drawn the picture. They've drawn it so that F appears two-dimensionally that it's on there, but isn't that popping off the page right here on this angled side or edge? That's why F and E are your answers to that one. So neither one of those are actually in the plane. And then your last question on this says, what is the intersection of plane ADE? So they're naming a plane. They've given 3 letters. So trace it with your fingers, A to D to E, and then connect back to A. There's that whole plane. And so on my textbook, somebody shaded this in, right? where's the intersection to this plane right here? Do you see that the intersection, the only place that this plane touches the paper, so to speak, is from A to D? What kind of thing is that? It's a line segment, so how are you going to note it? AD or DA with a line segment above it. Now, typically you're going to find out that the intersection of two planes is actually a line and not a line segment, but that's because these are solids and they're just snapshots. So we ended up with a segment instead of a line. All right, last slide.
Could you have said D and E? Do you know what half of it is on?
D and E.
No.
Yeah, E is not actually touching. Remember, E is not even in the plane,
Oh yeah.
so it can't be part of the intersection. But these are definitely in the plane. Only these ones are in the plane, and these are the only 2 points that that plane has in common with that plane. Does that make sense? Okay. All right, so then back PowerPoint. All right, so last slide. You've got a lovely rendition of a grid here. Do your best to plot those points on that graph. So it's telling you to draw and label a figure showing lines NP and QR. So I've given you the ordered pairs for NP, Q, and R. And you're to show that those lines intersect at point S. And so you need to put point S in there yourself. Bless you. Please connect those ordered pairs with a straight edge, because if you're trying to see the intersection, it's really hard to see it correctly if you're hand drawing it. Anything works as a straight edge, a notebook, a card, anything. You don't have to have a ruler. So when you connect your 2 lines, it should look something like this. Definitions that I have given you today. The intersection of 2 lines is a what? Is the intersection of plane? Is it a line? Is it a line segment? Is it a ray? Is it a point? What is it? It's a point, isn't it? This is an intersection right here, and on my PowerPoint I can't actually do the intersection, but that's the intersection right there. That's a point. You learned in Algebra 1-2 systems of equations. If there's a solution, one of the solutions could be one solution, one point. And that's the intersection right there, and you needed to label it S. So you need to label that point right there S. That's your intersection right there, S. Why did I choose S? Because they told me to name that intersection point S. So based upon that, we've got 2 things, and again, these should be on flashcards. Oh, because it's super slow, I'm going to put both of them up here together. So 2 points determine a line. That's how we do our line notation, but a line contains an in points. Similarly, 3 non-collinear points, meaning they're not on the same line, determine a plane. So we talked about that notation. And you might want to underline not 3 non-collinear points, because that's really important in naming your planes. A plane contains an infinite number of points, so both a line and a plane contain an infinite number of points. and that's it. So when you're finished, write down your homework on the sideboard, just page 16, 19 through 51 all. Don't forget to show your original problems, your work. Can I take this off of here now? Is anybody still writing it?
I'm still writing.
Okay. You can put your books back so long as you don't walk in front of the video.